Hi everyone, welcome back to my channel. Today we're going to look at KC calculations. So over this particular example, we are given that 0.92 moles of dinitrogen tetroxide gas is sealed in a 2 decimeter cube container and heated to 100 degrees Celsius. At equilibrium, it is found that 20.7% of the dinitrogen tetroxide gas has decomposed to nitrogen dioxide gas. Calculate the equilibrium constant Kc for this reaction at 100 degrees Celsius. That's an easy one. So first thing first, when you're given this kind of a problem, it is to make sure that you draw the table. Firstly, write down the chemical equation N2O4 at equilibrium to give you 2NO2. Now remember, in this particular problem, you are not told that this reaction, it is balanced. So you need to always verify whether the reaction is balanced or not. So the first thing that you need to do after writing this and of course writing down the table is to balance the chemical equation. So on your table, you will have the ratio, you will have initial mole, change in concentration, change in moles, and mole at equilibrium. And of course, the last one will be concentration at equilibrium, which will be number of moles over volume. Now we are given the volume anyway. So that's an easy one. So initially we've got what? We've got about 0.92 moles of dinitrogen tetroxide. And we also know that in this case, only one molecule of dinitrogen tetroxide has decomposed. So on our ratio, we're going to write what? 1. And on the equilibrium constant sign, I'm going to put a dash there to form what? 2 molecules of nitrogen dioxide. So how many molecules of nitrogen dioxide have we formed? 2 molecules. Okay. That's an easy one, and I'm going to put my dash there so that I don't forget and end up putting values where they are not supposed to be. All right. Now, what about the change? The change in mole is a tricky one. So before we get there, we need to know that initially the number of moles of nitrogen dioxide gas, it is 0 because the reaction haven't yet taken place. So we haven't yet formed nitrogen dioxide. Therefore, this will be what? 0. Does it make sense? Because we have informed it. Then let's look at the change in moles. The change in moles is an easy one to get because we are told that at equilibrium, it is found that 20.7% of dinitrogen tetroxide gas has decomposed to form nitrogen dioxide gas. So about how many? Around 20.7%. So I will say from my initial mole of 0.92 multiplied by 20.7 what? Percent to get my change in moles, which will be what? My change in moles in this case will be 0.19. Does it make sense? Remember, in this case, what is happening to the change in moles? In this case, dinitrogen tetroxide is being consumed. So since I am consuming it, it means I am taking it away. So it's going to be what? Negative here. Because I am consuming it. Can I just erase this quickly? So I'm going to say negative 0, what? 19. Remember from that 20.7% of this moles. Okay, that's an easy one. Over here, I want to know the change in moles formed of nitrogen dioxide because I am forming, I am adding. So the first thing that I should remember is to add because I am forming it. Now, how many molecules of nitrogen dioxide gas do I have? I've got 2 molecules. Therefore, it's going to be 2 times 0.19. So it's going to be times what? 2, which will give me what? 0.38. Okay, punch it on the calculator. So now I know my change in moles, so I can determine the moles at equilibrium. So for the first one, dinitrogen tetroxide, I will say 0.92 minus 0.19, which will give me what? Which will give me 0.7 So now let's continue with the moles at equilibrium for nitrogen dioxide, which is this compound over here. So we know that initially we've got 0 moles, and of course the change in moles being plus 0.38, we're going to add the change in moles to the initial moles, which will give us 0.38. Okay, now we're going to determine the concentration at equilibrium for both reactant and the product. So let's start with the reactant, which is dinitrogen tetroxide. So we were told that the volume of the container is 2 decimeter cube. So we will say number of moles over volume will be equals to the concentration. Therefore, we will say 0.73 divided by 2, which will give us what? Which will give us 0.37 moles per cubic decimeter. Do not forget the units. The units for moles for initial quantity will be moles. Change in mole, of course, it is in mole. Mole at equilibrium, we already know it is mole. Concentration, it is mole per cubic decimeter. And I'm going to put my dash there. And I will continue to do the same to determine the concentration for the product, specifically being nitrogen dioxide. So I've got 0.38 divided by 2, which is the volume of the container given to us. Our concentration will be 0.19 mole per cubic decimeter. Do not forget that. Okay, now we can use this concentration to determine the Kc value. So remember on our Kc value, Kc is equals to the what? The concentration of the products over the stoichiometric coefficient of the individual product that you have formed. So if ever you are forming more than one product, therefore each one of them will be raised to their prescribed or assigned stoichiometric coefficient. Do not forget that. Same applies to the reactant. So it will be concentration of the what? The product being nitrogen dioxide raised to its stoichiometric coefficient, which is 2 there and hence 2 over there. Okay. Over the reactant. The reactant being what? Dinitrogen tetroxide. It is raised to the exponent 1 because the stoichiometric coefficient there, it is 1. Hence raised to the exponent what? 1. Okay. Which will be equals to, now I can substitute my values. According to the CAPS curriculum, you don't use the square bracket when you are substituting values, regardless of whether it is concentration, because already there you indicated that this is concentration in moles per cubic decimeter, isn't it so? So you don't have to use, remember the square bracket represent what? Concentration. Do not forget that. So we will say open bracket for the product being 0.19 raised to the power of 2 all over the concentration of the reactant, which is dinitrogen tetroxide, being 0.37 raised to the exponent 1, which is equals to, and you can punch this on your calculator. This will give us, quickly let me do it for you, 0.19 squared over 0.37, which will be equals to 0.098. Okay, that will be our Kc value. Thank you very much for supporting my channel and watching this video. I really appreciate. Please do not forget to subscribe to my channel, and of course, until next time, bye bye.